Hello, everybody. Thank you for being here. Exciting days since yesterday. We've had at Mandapam. So thank you very much, firstly, for your resilience and for showing up for this very, very interesting discussion. We have a lot of wealth of experiences and expertise on this panel. So I'm not going to do a long-winded opener, just to say that obviously we're here to talk about AI compute beyond GPUs. I want all of us to be deliberate about this theme and this framing because all the other sessions will be about AI compute with GPUs. So let us think of this as a Venn diagram. AI can still exist in this part of our diagram, and that's what we're going to try to delve into. It is an aspect of AI that in the frenetic pace of development of large language models and AI for retail in general over the last couple of years, I think some of us have forgotten about. So this is also an attempt to revisit the fundamentals of how compute infrastructure is built from the ground up. So thank you very much to all the panelists for being here, especially guests from outside. I want to start off, Jason, with you. You are the CEO of the Information Technology Industry Council, which is a global tech advocacy body headquartered out of Washington, but also with offices in New Delhi. Very happy that you've made it in one piece. Can you give us like a 50,000, 60,000 feet view on where you think we're headed with the conversations around AI hardware when we think about the nature of globalization today? We're seeing a lot of reshoring of supply chains. We're seeing strained supply chains. We're seeing sudden disruptions. We're seeing dependencies. Tell us how to deconstruct this in 1 minute.
Oh, great. 1 minute. Okay, I got it. Well, first of all, thank you for all the work that you do at Cone Advisory to be a thought leader in these issues.
Thank you.
Really, really important. And thanks to all my fellow panelists and all of you for being here. So the 1 minute version is this. It's all down to trust. We have to trust in the ecosystem, the tech stack, if you will, in order to make sure that we're getting the products and services that we want and they're doing the things that we want them to do. And I think, as Vivaan mentioned, there's a tendency to think about the consumer applications of AI. And if you trust the service you're using, the AI large language model, or the software, it's okay. But there's an entire ecosystem behind it, from the data center that houses the servers, from the connections and the chips that are in those data centers, to the application layer, to the infrastructure. It all has to be part of trust. And I think the most important thing for us to focus on as part of that trust is trust crosses borders, data crosses borders. Large technology companies and small customers alike need to access the world. Most of the world's consumers don't live inside India. It's a big country, but there's a big world out there, and businesses want to be able to access it. So in order for government to have trust, we also need to have trust in the private sector. We need to work collaboratively, and we need to remember that these networks are global. So we need to take an international approach, which is why it's so exciting that the AI Impact Summit is here in India this year to make sure that India can help lead the world in building that trust.
Thanks, Jason. We'll come back to this theme. There's many aspects of what you've said that I'd like to go deeper into. But without further ado, can I turn now to Bhavna Agarwal, who's the SVP and MD for Hewlett-Packard Enterprises, which makes servers and various kinds of connectivity equipment, has a large workforce in India, as we were discussing today, some 20,000 people. So Bhavna, I want to ask you straight into the depth of this topic of what AI native architecture today really means, what it looks like, and what part you have to play in this.
So, when you look at it overall, in every conversation, usually when we talk about AI, it starts with GPUs, and it also usually ends with GPUs. But AI in reality is actually a lot more than GPUs. It's actually a system. It runs on a system. Whether you talk about, what Jason was also saying, it's about network, data, security. It's about software. It's about, the compute. Even if one part fails or gets weak, the whole system slows down. So when you look at the AI as a journey in its whole, right, that's the way it should be and not just one of the component. And if I were to further simplify this, let me draw a parallel, right? From a AI native architecture perspective. Let's say, there's a large city, and you have a tall building, which is GPU, right? Then you also need data, which is the road. You also need transport, which is your network connectivity. You also need the planning, which is the real architecture, that how it will really flow. So for you to have a successful city, right, thriving city, you just don't need tall buildings. You also need an efficient city planning. And that's what the role of an AI native architecture or the right good city planning is, because overall, if you were to look at it, AI has different needs, right from inferencing to fine tuning to training, everything. And because of different needs, it needs to sit in different environments. And that's why traditionally, we have seen that a lot of times you have traditional IT systems and people try to force fit and they put AI on top of it. But more and more industry folks are now gravitating towards building or designing infrastructure that is AI native, so that you're able to run faster, you're able to scale modularly, and you're able to deploy a lot faster. So industry is moving in that direction, and happy to go deeper into it during our conversation.
There's an aspect of city planning, as you mentioned, which is also which relates to design. And Naveen, not to pigeonhole you into the design part of the very long spectrum of things that we have to cover, but Marvell Technologies, of which you're a country head, is a design-led semiconductor firm. So can you tell us a little bit about what you do and how you contribute to this discussion through your design chops?
Sure. Thank you, everyone. So if you, we have started looking at from the tops down, but maybe let's go bottoms up, right? And then we thought the AI mean a compute, right? So compute is one important part of it, but along with compute, you need the whole network, because we are talking about connecting millions of them together to be able to train or infer. And then we also need a lot of memory and other elements to ensure that we can do the data access fast and then transport it across the network within the data center or data center to data center. So building up foundationally, what we see is that the compute is growing significantly, and it's not just the GPU. There are a lot of accelerators that needs to come up, that the security accelerators, the crypto accelerators, there are co-processors that needs to come in. There are smart NICs and others that needs to come in into a cluster that we form. And then imagine connecting them within the shelf to shelf, and aisle to aisle and all of that. And that's where you get to see the interconnects, which was probably significantly copper interconnect, but it started moving into the optical, which has come all the way from data center to inside the data center, right close to where your server is, to ensure that your data can move faster in both the training and the inference model, right? And then that's what we are seeing, is that the networking and memory are the walls, which is limiting your compute efficiency to be somewhere less than 50%. And that's where my analogy for what Bhavna said was that I come from Bangalore. Compute is a Ferrari on Bangalore Road, and if the traffic blocks it, that's not the best efficiency of the compute.
Thanks, Naveen, for laying that out. We'll unpack some of that. It sounds like almost like the early days of thermal power plants, where we're far away from like the ultra super critical kind of efficiencies. We'll come back to you. That I want to now shift tracks for a minute. You've got a little bit of a view, just a little bit, on centralized compute. Let's switch tracks to decentralized compute, and I want to bring in Wilson here. Wilson White is at Google, looks at policy around the Asia Pacific. Part of what you do, Wilson, is also to look at the pixel side of the story, and last mile devices obviously play a significant role in how we think about AI diffusion, and particularly in a developing country context. So over to you, Wilson, to paint us a story about edge AI, the kinds of characteristics of edge AI that you bring to the table, and why it's necessary in a Global South framing.
All right, thank you, Vivin, and thanks to Cone Academy for giving us an opportunity to spend time with you. I have a birthday this week, so thank you all for coming out to celebrate my my birthday. It's great to see everyone. Thank you very much.
Jason, you got to garland him.
But seriously, at Google, and I think Jason, Barna, and Nitin hit on this. Like, we are engaging at the full stack of this. And I love the fact that in this conversation, we're going beyond just TPUs because, as you said, Vivian, it's TPUs, it's the data centers, it's subsea cables and connectivity. It's also energy, it's the platforms, it's the applications that are running on this. But what's true in today's terms is that most people, and particularly if you think about the global south context or in developing markets, most people are interacting with AI through devices. And I know many of you, I've seen some Pixel devices in the audience. Thank you. Other Android devices. Thank you. For those of you who haven't converted yet, get there. But that's how most people are experiencing AI is on devices. And so we're also investing in that space. And we're thinking about compute both in big ways and small ways. Like, for example, in India last fall, we announced a $15 billion investment in India's first AI hub in Vizag, which has a gigawatt data center. It also includes subsea cable connectivity, new renewable sources of energy. And that's infra in a big way. That's compute in a big way. But we're also going small. And one of the things that we are doing is getting devices to have access to these large language models on device. So one of our new services is called Android AI Core, and it actually gives users of Android devices access to Gemini Nano, which is the smallest version of our Gemini models on device. And this actually creates some very useful experiences for users right on their device. Privacy by design. So you don't have your data leaving the device to go to the cloud. You actually are able to do things like have scam calls screened right on the device. To be able to interact with users as you are responding to messages in an end-to-end encrypted way because nothing is leaving the device itself. So we're thinking about how to ensure that all users can access the benefits of AI even on their devices.
Thank you, Wilson. Again, happy birthday. Yes. We'll build on from here with this theme on Edge AI with Becky Fraser from Qualcomm. Becky, thank you for making your way to New Delhi. You've been here before, and so I hope you have a good rest of your trip here. But just to build on the thematic area that Wilson touched on, what does Qualcomm do at the edge? What is hybrid AI in your lexicon? And what are the kinds of use cases that you're starting to see come online in the Global South? All in a minute or two, please.
Well, thank you all for being here, and thank you again for hosting this panel. And I love that I get to follow Wilson from Google talking about a very similar topic. It's wonderful to see the synergy. From a Qualcomm perspective, we think about the AI stack very expansively, from hardware to software, data center to cloud, large LLMs to small language models, and increasingly on-device processing. And when I say that, I'm talking about devices at the edge of the telecommunications network that are AI-enabled. So this is in your phone, in your car, smart glasses, increasingly across the factory floor and robotics. This is offering a capability. Hybrid AI is spanning from the data center to devices at the edge of the network. There's a number of benefits for edge AI in multiple markets, but as we focus on the global south, this really is an opportunity to have near instantaneous response, to have, again, privacy, building on some of the comments from earlier. But it's also an opportunity to have connectivity or AI capability when connectivity is existent or weak, because when you have the AI capability on the device, you can continue to run AI. One of the demos I encourage everybody to come see in the Qualcomm booth is Raxa Health. This is an Indian startup that developed an app where doctors can run healthcare analytics, note-taking in a medical context by voice, all on device. So they can take this phone that has connectivity or without, AI enabled, into rural clinics, and they can have a number of the benefits of AI in healthcare right in the palm of their hand. And again, that's an India-based startup that we're showcasing over in our booth, and we have a number of examples of that where Edge AI is bringing an entire new opportunity to innovate.
Thank you, Becky. So much exciting stuff going on. Yes, please do visit all the pavilions. I know PM Modi visited the Google one yesterday, but all the others also deserve a visit from all of you. Over to Sujit. Sujit, let's again switch tracks. You look at software as a vertical within Ciena, which is a telecom equipment and connectivity company. I think all hardware companies are becoming platform companies in some sense. You have to build different parts of the value chain now. But as far as network automation and the role of software is concerned, Sujit, can you dwell on that for a minute for all of us in terms of its importance in AI compute?
Check. Yeah. Just before I start, thank you so much for the opportunity, but just want to take a step back before your question. Have you all looked at the word India? How many letters? 6? Just look at the last 2 letters, AI, IA. Have you all thought about it? So basically it's a cliche where AI was always in India sometime back. Okay, with that start, let me tell you what's happening in the connectivity world. We can have compute, we can have memory, we can have, with all our colleagues who are sitting on this panel, but I guess the highway is what fiber connectivity comes through. And that's what one of the things that Ciena does. You would have heard of why these data centers are getting set up in India, apart from a lot of, I would say, cost pressures and other things, but it's about getting AI to the edge. Now, when you have to get AI to the edge, what you need is a nanomillisecond of availability before it touches you. So a simple example is, let's say you're looking at Instagram. So somebody in Rishikesh wants to look at Instagram. Do you think if there is a turn on your screen, will you like it? No, right? So I guess if you were to get that, the telecommunication industry needs to get fiber there. So one of the things that has happened is what is called as a new invention of hollow core fiber that has really come, which brings down the connectivity speeds by over 35% now. Now, the point of what one asked me about software is, how does software bind all the elements of compute, the availability, the applications, and all of that? So one of the things that I take as an example is about the OSS, which is operational support systems, where you are able to bind all of this together by way of getting all of this together, federate data, and give you an absolute good experience. So that's one of the things that it does. And automation is super important in this conversation. Any stack which brings near availability or I would say an availability of close to 100% is what is looked at. So that's one thing that's very, very important in this journey of AI.
Thanks, Sujit. It's not just all us workers who have to be always on these days. The networks, of course, have their load to carry. And thank you for doing the work that you do. Can I turn it over to now Abhishek Biswal, who is the Chief Business Officer for Digital Services at Airtel Xtelfi, if that's the right way to pronounce it. Abhishek, just building on what Sujit said in terms of the orchestration of AI workloads, a lot is now falling on the question of connectivity and the providers of connectivity services, whether it's between data centers, as was mentioned, or from the data center to the last mile. How is Airtel thinking about these things as a legacy network business, which is obviously expanding out into the world of AI?
No, I think as my colleagues mentioned, right, we talked about 2 words. We talked about always on, and we talked about reliability across the board. I think telcos around the world, not just in India, have to stop being passive carriers, which we've been for a very long time, to being the way to program your digital infrastructure. I think we have to make that shift, right? And there are 3 layers that, at least for us, we consider something that we should be investing in. The first one is connectivity should be intelligent. Today you have various types of access. You have fiber, you have copper. In some places you have 5G. I think we need to have deterministic latency. Today it's best case basis, right? How do we become deterministic at the latency that we provide?
What does that mean? Can you unpack that?
Today you expect a particular speed to reach you, right? Can you demand a particular speed? Can the carrier give you that offering so that you can shift between the kind of speed, the kind of latency that you want, right? Eventually it's physics, but software defined networks can give this strength back to the consumer or to the user, right? So how do you make that shift? How do you guarantee quality of service? So I think that's the first layer a telecom network should imbibe, saying how do we give that strength back to our users, right? The second my colleagues talked about is edge. How do we invest more in the edge so that better compute can be closer to the customer, right? It could be as close as the device, or it could be as close to the edge location where you can invest
CDNs and so
a
forth.
little more in, right?
Okay.
Finally, I think sovereignty is super important. Right? There are workloads that are going to be hosting public information, public infrastructure, right? So I think it means we need to be able to provide something which is secure, compliant, as well as resilient. So those are three words that we
Thank
think
you.
we should solve for.
Thank you, and thank you again to all the panelists for being so tight with their remarks, and I hope we maintain this cadence. Can I turn it over to you, Jason, because of the word sovereignty? It's a lot to unpack in itself. Various clusters of countries are looking at sovereignty in their own ways, just as they are trust. What is the way to build sovereignty and trust into the technology capabilities that we have around AI?
Yeah, it's a great question because some people think, and it makes sense, that sovereignty means independence. It means you close your borders around a particular product or service. But that's the opposite of what we need. So I think the most important thing to look at, and this is a great place to look at it, is how international standards, voluntary, industry-built, consensus-based standards for interoperability, for security, for safety, for trust can work. It's very important to build data centers in India to ensure that data can flow to India, but it's also important that that data reach the rest of the world, and there are standards for that. In the physical world, standards work very well. We're all familiar with them. As Wilson mentioned, everybody here has a phone, hopefully an Android phone, right? But there are other products and services out there if you don't, for some reason, want an Android phone.
It's a safe bet in India.
But everybody has, at the bottom of their phone, they have a charging port. And that charging port, probably USB of some kind, B or C. Doesn't matter what brand of phone you have, the charging port works. You can buy an independent charger. Those are global standards. They're technical standards. Here in India, BIS, the standard setting body, has published over 25,000 standards, but they're not all recognized internationally. Equipment manufacturers like Sienna that make things in India, there are India-specific standards you have to abide by. That means you can't necessarily sell that product to the rest of the world. So that's what I would say. Sovereignty is very important, meaning that countries have to look out for their constituents, their citizens, their consumers, and protect them. But we really should look to global standards, particularly around AI, to make sure we can access innovations from around the world.
Thanks, Jason, and also thanks for the shout out to BIS. BIS, by the way, is doing some work in AI. They have been part of the international standard setting operations at the ISO around AI. We've proposed 5 AI standards via the BIS to the ISO. So it is a work in progress. And Bhavna, just turning over to you, taking this thread of standards a little far into the world of sustainability, which is also an area which is being increasingly defined by standards, whether they're compliance standards or beyond just checkbox compliance, thinking about ecosystems, and how do we make sure that they're not just resilient, they're also sort of sustainable. And there's no pushback from society at some stage on AI diffusion because of the kind of loads that are being put on our grids and so on and so forth.
I think sustainability is extremely important because, as I earlier said, that a lot of times people equate AI with power and performance. But sustainability is extremely important because energy efficiency and environmental impact is as important as getting the right power and performance from your entire AI setup. And that's why, when we are looking at it overall, a lot of organizations, industries, governments are being a lot more conscious about the overall impact it is having, because when you're really designing something from day zero, we are now increasingly seeing a lot of players are now building sustainability not as an afterthought but from day zero as part of the design. Because when you do that, you're able to run a lot faster without giving up control. Because later you end up having a lot of band-aid kind of an approach where, because we need to do it either when the governments are asking for it or you think that this is the right thing to do. And that's why from a technology perspective, for example, at HPE, we've been doing it for almost 10 years. We have over 300 patents in liquid cooling alone, because we realize that more and more, especially when you look at high density compute, when you look at high performance computing, especially AI is very compute intensive, very performance power intensive, and more you scale, you require a lot more energy. And that's why we came up with liquid cooling, which a lot of people are now gravitating towards, or even for that matter hybrid, which is in a way a fan-less liquid cooling, because you're able to get a much better power output performance without having a much larger energy footprint. And when you're able to do that, you know that you are scaling up responsibly. So that's something we do see happening a lot more often. But regardless of whether organizations are moving towards hybrid, liquid cooling, or whatever it is, sustainability must be there as a principle on day zero, right? And not as an afterthought, because that's where we, no point doing it just as a tick mark, but for the right reasons.
So Sujit, can I actually take this thread to you and break the organic flow we've had so far? Because I know you care about efficiency, and software has a big role to play there. So can you build on what Bhavna said? Of course, there's liquid cooling and all of these technologies in the data centers, but again, efficiency from the point of view of getting that data from point A to point B, and thinking about the power needs of your connectivity infrastructure. How do you think about optimizing that without over-engineering?
I think
with your mic, thank you.
Just goes without mic always for me. Data centers in India, some stats for all of you. If you saw 6 months back, the predict was we would do about a gigawatt of data centers. That's the capacity everybody were thinking. But I guess everything shifted with the push and intensity from India perspective. We were to end 2030 by about 3 gigawatts. But guess what? I think by 2030, 32, I think we're going to be over a 6.5 to 7 gigawatts of power, which means India would stand at the top 5 from a data center capacity build. Now, when you build data centers and then efficiency comes into a big conversation, one of the key reasons is about how do you manage power, how do you manage efficiency, how do you manage, I would say, the lowest footprints, because building an data center which uses different kinds of power efficiency is super important. Now, as you get into the data center, I mean, from an efficiency standpoint, there could be 3 things that somebody can think about. One is called scale out. When you talk about scale out as a technology, you could think of something like this, where a typical captive data center looks at consuming a certain X power. Now, let's say you start to build a certain kind of technology around solutions like DCOMs that are available in the market today. The power utilization and efficiency can drop to as big as about 70%. So that's one thing which is coming out very, very clearly by a number of organizations. The faster you gravitate into it, the better data centers that you build. The second data point is about a scale up. How do you scale interconnects? We were talking about, it's all about capacities. You were talking about 100G, you're talking about 200G. I think we have got into a scale of plugs going into about 800G to 1.6. So which means to say that your ability to either inference or train your models are going to be much, much easier and sustainable. Now, thinking of data centers, which uses obviously what Bhavna alluded to, the liquid cooling technology, is very, very important. And using scale out and scale up is also very, very important. As we start thinking about these, you drive down the power efficiencies in a big way. And that's very, very important, building green data centers, including nuclear as a technology that you can use here.
Thank you. At some stage, we definitely need an intersectional discussion between the energy guys and the infrastructure guys. But over to you, Naveen. A lot of this is very hard work, which requires specialized skills. And, just thinking of something as basic as system architecture, I don't know how many system architects we have in India that are fully capable to respond to the needs of India. So it's a big area for skill mobilization and upskilling and so on and so forth. How do you, as a company which is obsessed with, high value skills, dealing with these kinds of questions in India?
Sure. I think there are two part to, again, the skills part, right? Means when we just look at AI, and a lot of people say it's artificial intelligence, I say it's an advanced intelligence. It comes from 5 different factors. You're bringing in the law of physics to get the latest and greatest, what we call as the transistors and everything else. So you need those. You bring in the latest and greatest tools, because we are talking about 200 billion transistors going towards 500 billion transistors on a chip. Will be 1 trillion by 2030 on the latest compute that we'll have, right? Add to that, we need the advanced packaging, because you are hitting saying how much cores can you put in a compute, and hence can you separate the memory and the IO from this and then package it all together. Combine it with advanced architecture. The reason I bring it, because the use case is very different, what we call as a workload. They're very different use case, and it all does not need the same compute and the attached fabrics to it. And then put all of this together in an advanced manufacturing and the design architecture scale, right? So you have skills that goes from what we call as the physics and the chemical, metallurgy, mechanical, thermal, all the way to the electrical computer architecture, and then to a system thinking. And the reason system thinking also comes in, because we are talking about now the scalability and the economics part of it, right? Can you scale, which means can you serve different workloads, and hence can you create the custom silicon elements to ensure we support it. Not one can solve it. And by way of custom, you can optimize the power and performance rather than just live with the same power performance curve that you will get from a traditional GPU, TPU, NPU, and all other processing units that you have. So there's a custom element to get to the scalable. And then when the economics comes, that's where we talk about the system integration part of it, because you're integrating the compute, the fabrics, the interconnect, the memory, and all of that, to be able to say that something can be fit in, serves the economics, and can be scaled to the million and billions of users. So it's all about building the foundational skills of science and solving the problem, but also looking at the system and being able to integrate so that we can get the best out of all of that.
So Naveen, it sounds like we shouldn't be as worried about the employment questions as we are today if we're double down on the real skills that are required to harness the potential of this technology. But that's a debate for another day. Part of this, however, Wilson, on the softer side, not on system architecture, but none of this matters if there are going to be no apps, no users to experience the experiences, the wonderful experiences that AI brings online. And so part of this is also, it's incumbent on us to think about what are the kinds of developmental activities that are required to actually bring AI into our everyday lives. Obviously, Google as a platform has enabled that through the App Store for years. But how are you thinking now about the next decade of app development to boot?
Yep, thanks for the question. And I'll start by starting where Jason started our conversation on trust, right? It's as we think about developing and deploying this technology, trust has to be at the core foundation of that. Otherwise, this huge demand that we're seeing for AI applications won't exist, right? So people must trust the systems in order to want to use them. I like what Naveen said around like the skills that we have to have. One of the things that we're thinking about at Google is the fact that we're going to need semiconductor engineers. We're going to need folks who are doing the hardcore skilling, but we're also going to need doctors and lawyers and plumbers and farmers. We're going to need all of these jobs. And so we need people to be able to exist in an AI-powered economy. One of the areas where we're seeing that play out, I think, in the mobile space and in devices is with app developers. Those are the folks who are building experiences that people are using. And one of the things that we're trying to do to help developers do that and kind of come up the curve in terms of AI is making AI more accessible. So we have an Android Studio, which is our developer suite for developers who are developing Android apps. We have a new software suite that we call Agentic Mode in Android Studio. And this is allowing developers to just describe a feature that they want to be able to build. And the AI technology is then turning that description into code and getting applications out to users much faster. That's one way that we're trying to tackle this. But I would just say one of the things that we're working with the government of India on is not just helping upskill the population on AI, but also thinking about how we reimagine education altogether. Because the way we approach educating our young people to be ready for an AI-powered economy is going to be very different from how we all grew up in the education system. That's an area where it's going to take an all-of-society approach to do that, and we're very committed to doing that here in India.
Thanks, Wilson. I may become an app developer. You make it sound so easy. This whole vibe coding thing, I can get on board. But Becky, can I turn to you just to expand that use case part of the discussion? You mentioned Raksa Health and your demo outside, but are there other interesting use cases too that you'd like us to know about? And also, since Wilson brought the government of India into our frame, are there some policy frameworks, and I'd encourage the other panelists also to reflect on this, that you think have worked in other global south contexts or any context that you think we can adapt to here to promote edge AI, hybrid AI, efficient AI, whatever you want to call it, inclusive AI?
So from a Qualcomm perspective, as we look at the next phase of AI and understanding really moving the compute capabilities to where data and people are using devices and where the data is housed, which is at the edge of the network. So when we look at use cases across the global south and India, there's a lot that's emerging in terms of agriculture, where we're seeing some robotics having the ability to test for insects on certain crops. We're obviously all familiar with drones using positioning in order to detect for drought or circumstances on certain crops or for watering. Again, the healthcare space is a really exciting incubator of new ideas, Raksa Health being one, but there's several others. Another great Indian example is, I think it's Sight Signal. HearSight, thank you. HearSight, where a gentleman in Mumbai lost his sight at a young age, and he's developed technology on glasses that is delivering a message as to what the glasses are seeing into his ears so that he has an entirely new, expansive range of mobility. So again, I could natter on about use cases. There's a lot that's exciting. One of the things that we're doing in this space is the Qualcomm AI Hub, which is where we're bringing different large language models and small language models together with virtual versions of devices, phones, cars, computers, so that the app developer community can go to the Qualcomm AI Hub and they can virtually run their Edge AI app on a virtual device using different language models of their choice. So from a policy perspective, we very much want to see the encouragement, great work of nurturing the startups, continuing the academic collaborations. We personally like the Vietnam examples where they have a number of policy milestones that they're working toward for IoT connections per citizen by 2030. They also have a really ambitious smartphone milestone marker. I live in Singapore, and I'm always impressed with the sea lion and merlion goals that government has. So I think it's a combination of setting some market signals from governments that they want to see edge AI. They want to see more use cases and deployments in their market so that all of our companies get organized to deliver that. And then obviously, again, the innovation policies that we're all familiar with continue to be really important.
So you've touched on something very important, which is why I want to turn it back to Wilson for just 10 seconds. Wilson, we haven't through this discussion talked too much about privacy, sensitivity of data, and obviously if you're processing this stuff at the last mile, hopefully you're building some guardrails. Would you like to spend 10 seconds on that before we move on?
Giving me a microphone for 10 seconds is almost impossible on this topic, but I will say yes, for us, privacy by design is how we're thinking about this. And we have a great partnership with Becky and the folks over at Qualcomm, who are our partners in ensuring that as we think about on-device, we're building privacy as part of that, part of our thinking from the design standpoint.
Thank you. Glad to know there's some work being done on this. Abhishek, we're switching tracks again, and this time it's on the economics of making all of this stuff work. Telcos historically been obsessed with quarter-on-quarter ARPUs, and obviously AI represents an opportunity in terms of continuing to work on that, adding more value for your customers. But AI is also super expensive to deploy at scale, and it costs money to get networks ready. Again, it's like the energy analog of having first generation network infrastructure, and suddenly you need to make a smart grid, and you have all these renewables you've installed, but somehow they don't, it's hard to orchestrate this whole thing and offload that new energy into the grid without causing collapse. How do you think about the economics of this business going forward?
So I think...
and you are the chief business officer, so I know you're thinking about this.
See, we've... and Airtel or any telco will always operate at the intersection of cost and scale. So heavy capex cycles are not new. I mean, we've seen waves of capex cycles in telecom, and every time you start, you look at hardware being expensive, right? It's a hit that you take, but if it's sustainable in terms of business impact, it comes back, right? So the way that we see this is, hardware costs can fluctuate. They can go up, they can go down. It could be super expensive today. It may not be as expensive tomorrow. The way you architect the use of this hardware is what drives sustainability. And investing based on a currency, and that currency could be customer experience, it could be ROI, it could be how do you take ARPU up, right? And having a very sharp focus on whether that is moving is key to sustainable investment, right? So get it right at unit economics, keep driving consumption, keep driving...
I just want to press you on that, Abhishek, and I apologize in advance if this is off the script. But 5G networks monetization, still a work in progress in India, and suddenly you have this new workload to orchestrate, so to speak. Is that a bit of a challenge from the capex side, or you still feel optimistic about optimization?
So we always feel optimistic about optimization. I think, see, as a culture, we have this term that we call, we don't talk about cost control, we talk about war and waste. So if we think there is some investment that is not going in the right direction, don't stop the investment. It's best to invest quick and fail fast, right? So that's how we see this. It allows us to experiment a little more than we would if we were very, very conscious about it. But as long as you're investing and getting to the right architecture or the right business economics, you will see, I mean, we see Airtel really propelling good money after good investments. So that's how we would like to really look at it.
Bhavna, just to turn this question over to you. You are also a business leader and you have to think about this stuff, because from the demand side, are folks demanding that you somehow turn this new age infrastructure of sorts around at lower costs, year on year? And if so, how do you do that with everything becoming so prohibitively expensive?
See, if you remember just about a few minutes ago when I was talking about sustainability or about AI native infrastructure, what really matters is when you look at it as one coherent unit, as a unified strategy, you are able to then make it a lot more predictable in terms of cost. And there is this also new, way of doing it in terms of bringing modularity into how you're really designing the entire architecture. Because when you do that, a lot of wastage does not happen. A lot of over provisioning does not happen. Because as I said that, it's not about, and also it's a myth that it is all the time expensive. Depending on what you really want to get out of it, it's thankfully in India, it has moved away from experimentation to execution now. And that means a lot more people are now looking at it that what do we want to get out of it? Depending on that, what is the ROI that I want? What are the use cases I want to see, especially in the beginning? And when that happens, then you involve this modularity, then you design it in this manner that you only deploy in small clusters. You experiment, you see that what is the result you're getting, and then you bring that predictability in scale up. When you do that, rather than one knee-jerk reaction of saying that let me just deploy something because I want to experiment, and then you try to force fit things, it will always turn out to be expensive. But we have been seeing this not only across the world, but also in India. It is cost efficient if you design it responsibly, if you design it thoughtfully, and you make it accessible. You'll be able to deploy faster, control cost, and make it sustainable.
Thank you, Bhavna. That's very elegantly put. I think there's also an element of responsible sales here, because if your salespersons are upselling on the value proposition versus making it modular, then it's difficult for the customer to kind of unbundle. But thank you for those remarks. We have 5 minutes left. If anyone has a question and not a comment, please direct that question at the speaker you want that question to be answered by. Please introduce yourselves very quickly. This gentleman, question.
So I'm Vijay Kumar, I'm a research scholar. So you want India to be a hub to provide services for different platforms for the entire world. So how do you think number of data centers are required for India in such scenario?
So I think Sujit answered part of that, but yeah, go ahead.
Yeah, Vijay, that's a good question. It's not about how many data centers, it is about how efficiently, without spoiling the environment, we would build data centers is important. I know we are a very large market, billion plus people. We would like to deliver services and everything else to the citizens in the most effective way. It's not definitely not the count. The scale of, like I alluded to this point of saying, we might get to about 6 gigawatt of data center capacity in less than by 2030. I guess by 2035 we should get to a 16. But the point is how responsibly we bring it is going to be very, very important.
Sujit, you're setting yourself up for the data centers and space question, but I won't ask that. Yes, this gentleman here, your name and please direct it at a particular speaker.
And my question is from Google, Qualcomm team and Marvel team. It's around how shifting from GPUs to CPUs or AI accelerators or something similar to TPUs would be involved in the shift for GPU alternatives.
Okay.
Other than that,
That's it, one question per person. Would you like to take that first?
Yeah, so that's what I mentioned when we said that the starting point was GPU, because that fit in with the parallel processing and the matrix valuation that we are doing. But as we move forward with the different workloads, the very different workloads you could have on the input side, which is audio, video, text, 3D, all kind of things, and similarly on the output, and multiple use cases. And hence, you need that custom processing unit. The TPU, NPU examples that you take is already there. And then as you go to any hyperscalers or any of the upcoming hyperscalers, it's a lot of combination of what we call as the traditional GPUs that you can procure, but as well as the custom that you make, which is optimized for both power, performance, the use case, the cost, the power, thermal, and all of that, so that you can scale at the economics that we are talking about.
Thank you, Naveen. Yes. And we'll take a few from the back soon. Question and name.
So, my name is Akshay Shwasta. So, building onto the similar question, I want to know that what are we doing to build onto the GPUs and TPUs such that it can be utilized without much of the natural resources, as well as there is no much exponential increment on the computation power that we need to build.
I think we've been answering questions about optimization. Is there a different question here in the mix? Yes, from the back, this gentleman, yes. Sir.
The question is to Abhishek.
Hmm.
You mentioned in your first intervention about that the telcos need to actually provide quality of service, a better quality of service, and
A uniform quality of service.
uniform quality of service. Instead of saying up to a certain speed, you provide the speed which you have actually given, for which the data plan has been bought by the customer. My question is, what is stopping the telco from doing that? Why is it there is a kind of a reticence on behalf of the telco not to offer that what has been paid for by the customer? Don't you think that is absolutely a must?
I think Debuji is also channeling some of our experiences in the room with bandwidth, latency, etc. in our homes, but over to you.
I think two things. Our ambition is always to do as much as we can for everybody. And that's what networks in India do. They're pervasive and they will provide you a quality of service, and we don't differentiate users between one or the other, right? So our telecom license does not allow us to differentiate. I think on the enterprise side, we've been for a very long time providing the quality of service that's promised, including observability and being able to measure it. I think what's missing today, and what the ecosystem can come together and do, is have an ecosystem of not just connectivity but also edge devices to give us that feedback saying what's working, what's not working. Today, quality of service is speed. I think application uptime, your ability to hit a particular data center and come back, those are metrics we don't track or we don't transparently share.
Sujit, would you like to build on that? Because I know you make routers and so on.
Itching to talk. So two things, because I come from the telco world. One is, and we talk to Airtel very, very closely. I can guarantee you, every time they talk to us, they say, can you build what is called as 8-cut knockout? 16-cut knockout, which means to say that the number of fiber pairs that are put to deliver a certain service to you, the Bashish ji, is over 8 pairs, 16 pairs, up till 96 pairs of fiber, depending upon where they want to put. The second point is delivering quality of service that Abhishek alluded to, and that's where the software hat of mine comes in, is how do you use agentic AI to do this, I would say, balancing of act, so that, whenever you have a problem, you call somebody, the ability to quickly analyze what the problem is by use of agents is very, very important. So I think today on the OSS world, there are agents built wherein which can quickly, without you talking, explaining it, if you answer 2 questions or 3 questions, and looking at the background of the telco side, they will come back and tell you that your cut might be 90% due to a router problem and a hardware issue versus actually, the fiber. Yeah. The fiber could have been stable there.
Same question very quickly to Wilson and perhaps Becky, if you want to take that as well. From a devices point of view, quality of service, how important is it to you to build in?
I think it's hugely important, but maybe I'll just end quickly with a cliffhanger for next year's summit, which is an area that's coming down the pike pretty quickly here, and that's around quantum, and how quantum is going to help with things like quality of service, like optimization and some of the other things there. A lot of research happening in that space, but also practical applications. We have our Willow quantum computing chip already that's has been developed. So keep an eye on that space.
Thank you. Becky, any final remarks?
I would just quickly offer AIKC did a great use case compendium of AI at the edge use cases, which I would really encourage everybody to look at to be a bit more familiar with what is on the horizon.
Thank you very much to all the panelists. There are throngs of crowds outside waiting for the next session. But this has been most enriching. Thank you again for
Vivan,
coming together. Yeah.
We just request Brigadier Tandon to hand over the mementos with Wilson White